Okay, today we're going to try and build half of the unit circle, and we'll do the other half together in class. But before we do that, we started looking at bits and pieces of this. So I want to reemphasize the difference between a point being on the unit circle and the point on the terminal side of an angle. So if you see something that says on the unit circle, it's going to give you an X and a Y. Automatically, you know that's a cosine comma sine. Cosines correspond to X, sines correspond to Y's. Okay, so if you see, something square root of 5 over 7, comma 2/3 is on the unit circle, automatically there's your cosine, there's your sine. Okay, if it's on the unit circle, that means the radius should be 1. I doubt these work out that way because I just made them up right now, but the numbers I give you will work. Okay? When something says a point on the terminal side of an angle, that means it could be, really any ratio of triangle on that angle. Okay? So that does not give you cosine and sine directly. You're actually going to have to go ahead and plug these in. So let's say it says 5 comma 6 is a point on the terminal side of an angle. Okay, so you're really just going to draw a picture of where 5 comma 6 is, like this. Here's your theta. So that means we went over 5 and up 6. This is not the cosine of 5, and this is not the sine of 6. Okay, the sine of this would be 6 over, and then you'd have to do, Pythagorean theorem to find the square root of this. So 36 plus 25. Okay, so that's the difference between them. On the unit circle, it's a cosine sine. On the terminal side of an angle, you need to draw a triangle and then go grab values from there. To build the unit circle, okay, we're going to use 2 special triangles, and we're going to do quadrants 1 and 2 on this lesson. In class, I'll have you guys do 3 and 4 together. Okay? If you can build it in quadrant 1, you can build it in all 4 quadrants. So first thing we're going to do is get our 2 special triangles that you might remember from geometry. 45, 45, 90. We can't do any sine, cosine, tangent stuff unless they are right triangles, so that has to be a given. So first one is, if this down here is a 45, automatically up here has to be a 45 as well. Okay? Now, there's 2 ways to think about this. Okay? We said that the radius of a unit circle always has to be 1. Okay? If you put the radius at 1, it makes these fractions down here. Okay? I think it's easier to stretch that triangle out and just change the scale and then have whole numbers everywhere. Okay? And we'll discuss that difference in class as well. Okay, so your 45, 45, 90 triangle is a 1, 1 square root of 2. Okay? If you were to have it as a radius of 1, it'd be 1 square root of 2 over 2 and square root of 2 over 2. These are the exact same thing here. Okay? But we're going to use this one because I think it's easier for you guys. Okay? So this is what it would actually look like on the unit circle. We're just stretching it out and scaling it so we get whole numbers everywhere. Okay, second special triangle is the 30, 60, 90. So it really we can have 2 different little reference angles down here. We'll put the 30 down here, we'll put the 60 up here, okay? Across from the 30 is always going to be the smallest. That's going to be a value of 1. Okay, across from the 60 is going to be a square root of 3, and then your hypotenuse is a 2. So even though we call it a 1, 2 square root of 3, watch out that you don't put the square root of 3 as the hypotenuse, okay? Square root of 3 squared plus 1 squared equals, 2 when you do your Pythagorean theorem to check for that. Okay, so 2 is the biggest one. It should be on the hypotenuse. Okay, with those two triangles, we're going to build the unit circle. Okay, so we're going to basically go around the unit circle in multiples of 30 and 45 and 60, but that comes with the 30. So we're going to start in quadrant 1. We're going to do 30 degrees. It's one of our special angles. Okay. Try and also get in your head 30 degrees is the same as pi over 6. Okay, 1/6 of the way over to pi. Okay, so 30 degrees is going to be in quadrant 1. So we're going to draw a little picture like that. And then we're going to blow it up. So this is what we're looking for. Here's 30 degrees. We have special values now. 1, 2, square root of 3. From this triangle, you can fill in all 6 trig functions. Sine of 30 degrees, opposite over hypotenuse, is 1/2. Cosine of 30 degrees, adjacent over hypotenuse, square root of 3 over 2. Tangent of 30 degrees. Okay, tangent is a TOA. So opposite over adjacent, 1 over square root of 3. You want to make sure you rationalize all of these. Okay, so I always do a sine, cosine, tangent in some order there. Okay, maybe cosine, sine, tangent. Then do the reciprocals and always have them match up. So if you have a sine up top, put the cosecant with it. Because now all a cosecant is if you know your sine's correct, all we have to do is take the reciprocal. Okay? For whatever reason, it's tough for me to do cosecant off of a triangle because hypotenuse over opposite is so different than opposite over hypotenuse. So I just take the sine and flip it. Okay? So then a secant then. I'm just going to take my cosine and flip it. Okay, you do want to rationalize this though. Now a cotangent, don't take our final answer here for the tangent and flip it because you're going to be rationalizing it. Take this original one and just flip that. Okay, there's your 6 trig functions for pi over 6. Okay, so next stop is 45 degrees, which is 1 pi over 4. Okay, 1/4 of the way over here to pi. So draw a little picture. Where is 45 degrees? It's quadrant 1. We don't have to worry about any negative signs here. So we pull this picture out, make it nice and big. A 1, 1, square root of 2. Okay. Now we go through all 6 trig functions here. So sine of 45, opposite over hypotenuse. You do want to rationalize this. Okay, cosine of 45, adjacent over hypotenuse. Rationalize it. 45s are nice. Sine and cosine will always be the exact same value. When you get into different quadrants, they'll start being negative while the other's positive or whatnot. But 45s are nice, sine and cosine are the same thing. Okay, but make sure they're rationalized and no decimals. So now tangent of 45, that one's actually pretty nice too. There's 2 ways to think about it. Opposite over adjacent for the TOA is 1 over 1. Tangent is also the same thing as sine over cosine. Y over x, if you put sine over cosine, those are going to reduce down to 1 as well. Okay, 45s are nice. So cosecant now. Again, don't take your rationalized one and flip it. Take your original before you rationalized it. Cosecant is square root of 2. That means a secant is the same thing. Flip the cosine. Okay. Now, when you're doing a cotangent of 45, when you flip a 1 over 1, you still get 1. Okay, watch out when you start getting into 1s and 0s though. Okay, so part 1 there. Well, first video, we got through 30 and 45. Part 2, we'll start up with 60 degrees and then quickly do quadrant 2.